This video goes over the next lesson, antiderivatives and indefinite integrals. So all through math, we've had a way to do and undo things. To undo addition, I use subtraction. To undo subtraction, I use addition. To undo multiplication, I use division. To undo division, I use multiplication. To undo squaring, I use square roots. To undo square roots, I use squaring. And then we could go on forever, but I'm going to generalize this. To undo x to the nth power, I do the nth root of x. And to undo the nth root of x, I use x to the nth power. To undo exponentials, log or exponential base b, I use log base b of x. And to undo log base b, I use exponential base b. So we've spent the whole first semester learning how to do derivatives. So if this is going to continue, there must be some way to undo derivatives. So we're going to look at three derivative rules that we know. This is called the power rule. The derivative of y equals x to the n is n times x to the n minus 1. The derivative of y equals e to the x is y equals e to the x. And the derivative of the natural log of x is 1 over x. We also have these if we have a different base other than e, but we're not really going to do much with those. So these are the three we're going to look at. So to undo the power rule, so if I have this little thing that kind of looks like a stretched S, it's kind of from the summation symbol, but if I have the integral of x to the n, and then I put a dx out here always, and we'll talk about later where that little dx came from. So if I want to go exactly opposite to this, so here I took the n off the exponent and multiplied it times the front. And then I subtracted 1 from the exponent. So what we're going to do is do exactly the opposite. What's the opposite of subtraction? Addition. So I'm going to add 1 to the exponent. And what's the opposite of multiplication? Division. So here I multiplied by the old exponent. Now I'm going to divide by the new exponent. And then we have to do something that seems a little bit counterintuitive right now, but we're going to say plus c. And I'm going to show you where that plus c comes from right now. Let's say I had a function y equals x squared plus 3. So if I did the derivative of that, so I said dy over dx equals, I would bring the 2 to the front using the power rule, 2 times x, I'd subtract 1 from the 2, so I get a 1 that I normally don't put, and the 3 disappears. Now, if I take this dx and multiply it times both sides, I get dy equals 2x times dx. Now what I'm going to do is take the integral of both sides. So I take the integral there. So this is going to be just y equals 2. This is x to the 1, so this becomes x squared divided by 2, and then I put the plus c in here to account for, there could have been a constant here that when the derivative was taken, it was destroyed. Now 2 divided by 2 cancels to a 1, so we get x squared plus c. So we'll do a couple more of those things. So I'm going to start a blank page here. I'm going to say the integral of x cubed dx. So I want to add 1 to that exponent, So that's x to the fourth, divide by the new exponent 4, and then plus c. Can we do that in the calculator? Sure. So we'll do that in the calculator. So previously, to get a derivative, we did shift minus. Well, if we're going to do the opposite, guess what we do to get an integral? Shift plus. And right now, we're not going to use these first little rectangles. So I'm going to go tab, tab, x to the power of 3, tab, tab to get over to here. This variable right here has to match this one. Now, the calculator does not put in the plus c. You have to know to do that yourself. So we get x to the fourth over 4. Then we're going to go on to the next one. This is pretty simple. So if we've got the integral of e to the x dx, that's just going to go backwards. That's e to the x. Then I do have to put in the plus c. So say I had y equals e to the x plus 5 dy over dx equals e to the x. The 5 went away. So if I multiply both sides by dx, I get dy equals e to the x dx. Take the integral of both sides, y equals e to the x plus c. So that one's pretty straightforward. We'll now go on and do the last one. So I have, if the function is y equals the natural log of x, the derivative is 1 over x. So if I'd take this, I'd get dy over dx equals 1 over x, multiply both sides by dx. So if I do dy equals 1 over x dx, take the integral of both sides, I get y equals the natural log of x, but the natural log doesn't play well with negative numbers, so we're going to throw an absolute value in there and then say plus c. And with those 3 rules, we should be able to do the homework. And that concludes this lecture video.